you everyone for sticking with us till the end of the conference. And I'd really like to thank the organizers for getting this invitation, especially Di and Rob are the ones who relayed it to me. Like Roger, I've been using R and S before that since quite a bit back into the 90s. And so it's really a great honor to be invited to speak at UseR. And it's always one of my favorite conferences. I have the easiest time finding talks that I want to hear, and I love the diversity of talks. I feel like especially these keynotes, there's like different genres of keynotes, and this is going to be yet another point that's quite different from the others, but I've truly enjoyed all of our days together. This is the Code Smells and Feels talk. Hopefully this short link takes you to a GitHub repository where you can find everything about this talk. So the slides would be there and a way to view them. And before long, we're going to look at a lot of snippets of R code, and that's there as well. I think that's all I have to say here. So Roman showed this slide in his talk, what the effect of the tidyverse weekly team meeting is on babies. And this is actually my practice talk. I've practiced this talk several times in front of that group, and so my hope is that we get a different result today. As Thomas mentioned, I have a long and circuitous route to my current position, and in some sense I'm uncomfortable with this title. So I majored in German and economics, then did management consulting, and then pursued a statistics career. And you'll notice what's lacking here is any sort of formal training in computer science or programming, and this talk is very much about acquiring that for yourself later as a self-taught person. And I was wanting to know, and I had a hypothesis that I am not that atypical, that lots of us come to R with very little programming experience, and some people just want to analyze data and they get in and get out. But some of us, like me, discover that you really love this. Like, I like the way it feels inside my head to work on these things and decide to pursue them more seriously. So I tried to think about a data set that exists that gets at this. And so I asked Julia Silge, who's a data scientist at Stack Overflow. They have, I thought, a pretty good data set for this. So they survey users of Stack Overflow once a year. And she pulled out, well, she knew how to use the public resources. Once she showed me, I knew how to do it too. You can look at all the people who declare themselves as they use R versus they do not. And you can look at their self-reports in terms of what they majored in as an undergrad. And sure enough, you'll notice that computer science, computer engineering, software engineering, information systems, information technology, and other system administration is pretty substantially underrepresented as the background of someone who uses R. And we have much more, well, math and stat, obviously, and then domain knowledge, which is probably how we got here anyway. So, but these kind of differences are like 65% of the other people majored in computer science, where less than 45 of you R's did. And that's of those who show up on Stack Overflow. So I think I'm not atypical in trying to really level up my skills later. And I want to give credit to Martin Mechler, really for the type of talk that I'm giving. And he actually just referenced this in his talk as well. So I think this was the first UseR, yes? 2004? He gave a talk called Good Programming Practice. And it made a big impression on me. And he's been giving updates over the year. I think the most recent version was in ERUM 2018, quite recently. And what I loved about this talk is, to me, it talks about all the sorts of things that no one talks about, but that actually like heavily influence how effective you are in R. And then inspired me to create several talks. And I tackle different topics because I work on different things. But for example, I'm a big proponent of having a workflow, because I feel like I have spent a lot of my time as a data analyst with a bad workflow, and that in some sense would block me more than not knowing how to write the next line of R code. And so the Code Smells and Feels talk is another in that series, but it is different. We will not be talking about workflow. So this is how I would describe the process of getting better at writing code, I think code is very much a craft, and there's a lot of room for creativity. But there are also objective measures of some things are good and some things are bad. For example, being correct, being extensible. There's all these qualities that they aren't completely objective, but they're awfully close. And so, as you'll see, also in that link I sent you to, there's like an annotated bibliography for this talk. But this is a paraphrase of a quote from an interview of someone called Ira Glass, who's a journalist in the US, and he really pointed out the agony of him getting better at journalism is that your taste for what you want to produce and what you can appreciate develops much faster than your ability to execute that. And so being able to push through those multiple years where you know your hedgehog cake does not look like the other one, and to keep at it anyway. So the way this looks for me, as Martin recommends, I read a lot of source, not only of these people, but I picked these 3 individuals who you may recognize. We will leave them unnamed. Some of them are in the room. As the people I interact with the most on code. I read a lot of their code because starting to take over maintainership of some of their packages or co-maintain packages, discuss code a lot with them, get code review, receive code review. And so sometimes I feel like my code doesn't quite smell like the code they produce. So I can recognize the difference. And then you want to know, you don't want to be told every single time, do this, do that. You want to be able to do that for yourself. So a mechanism that gives you entry into this world, and there are many, I'm sure, but there's a notion, and you're going to learn, it's quite formalized. I didn't make this up. I don't want to take credit for it. The idea of a code smell. When you open up a file and you're like, oh, it's just not the kind of code that you are eager to start editing, and it could be written by you. That happens to me a lot. Or it can be written by someone else, and then there's patches of it where you're not super eager to get involved, but you need to. So this term actually comes from a book called Refactoring by Martin Fowler, who also has a really interesting blog. So let me give a lot of credit. We're actually basically we're going to work through a chapter of this book, but in R. So he wrote this a while ago, and I think it's about to come out in a new edition. And so he and Kent Beck, who's a pseudo co-author here, coined the term, I think they coined the term code smells. So what is a code smell? It's structures in code that suggest or scream for, that's their word, refactoring. What is refactoring? That is making code easier to understand for the next person, which might be you, cheaper to modify by the next person who comes through without changing its behavior. So I'm going to give you very concrete examples and tips that I think should apply broadly, whether you were at the R Curious workshop on Wednesday, you're really new to R, up to package maintainers, who are probably a bit more of the audience for this. And for package maintainers, this means you need to have tests before you really start monkeying around with things, which is not a topic of my talk, but that's what gives you the freedom to refactor. So when you sit down and make rules for yourself about how you want to improve your skills, you can find a few absolute rules, and not everyone would even agree with these, but some that you hear and that, I pretty much buy into these two. Don't use attach in general, and don't put a space, or do put a space before and after an equal sign. Okay, but what you'll notice about absolutes is they tend to either be really superficial. I also don't think it's that important if you put a space around your equal sign, or extremely narrow. So there just aren't that many situations where knowing this fact helps you make the next decision about your code. So these absolutes tend to be narrow or superficial or both. Then you have these vague exhortations that people tell you. Have better taste. Write more elegant code. And of course I would love for both of those to be true, but I don't really know. It's not actionable. It's way too vague. And so I think this methodology of thinking about code smells, and once you feel like you've identified one, there are lists of accepted refactoring moves that are relevant to individual smells, and it gives you something concrete to start working on. And the other thing I like about this is not all of us are writing a lot of maintenance code. That is a lot of what I do. But there's also a term based on refactoring called prefactoring, which is if you do enough of this refactoring, it also starts to really influence the way you write the code the first time. So I think it's an interesting discipline to help you in both scenarios. All right, so we're going to do a quiz. The code smell names are spectacular, and I'm about to show you some. And I'm going to give you about a minute to chat with your neighbor and determine which ones are official code smells. I guess you can use the internet, but that would be super lame and cheating. Could it be a romance novel, legal instrument, quilt pattern, movie franchise, or Prince song? So here are the smells on the left. I'm reminding you of your choices on the right. Take a minute if you're feeling social and someone's close by. Try to spot the smells versus the other things. Okay, I'm sorry to put an end to maybe one of the more interesting conversations. I also found that this talk generated lots of conversations among the people I practiced on, which made me think it was a good topic. So let's do the big reveal. And actually, I'm happy for someone to shout these out. So what do we think too hot to handle is? Okay, there's no consensus whatsoever. So no one's... wait, I did hear romance novel. So has anyone read Too Hot to Handle? It looked like a fairly tasteful romance novel on Goodreads. Primitive Obsession. Definitely a code smell. Nice. See, I think it sounds like a perfume. Forbidden Fruit Tree. Quilt pattern. You guys are good. When Doves Cry. Yes. Inappropriate Intimacy. Yes. Fast and Furious. Restraining Order. Middleman. Okay. So my challenge to all of you is I think these are perfectly valid names for code smells. So we can make them happen. For example, I think Fast and Furious would be perfect for code that's over-optimized for speed, but would be very hard to extend or read again. So anyway, I invite you to tackle these. So this is the official list of code smells. I'm thinking some of you have looked at this before. I highlight a few either that are related to what I'm going to talk about or that I find especially delightful. And so they're not all quite as funny, but some of them are. And the point of my talk, I'm about to delve, surprisingly so, into the weeds of we're going to work through a lot of elementary R code talking about this. So, and I picked my example because I think it's actually relevant to a lot of people, but I also want you to know that if this type of exercise seems fruitful to you, there's a whole world out here of code smells that you could start to detect and work on. So we are actually going to work through the chapter of this book. So chapter 9 of refactoring is on a general set of refactoring moves for simplifying conditional logic. And I picked this. It's probably the one that speaks to me the clearest. It's the code smell I feel that I'm best able to detect and that I want to do something about. And I feel like it's relevant to people just learning to write R versus people who maintain a lot of packages. So I give you Bizarro. Bizarro is going to be our function that we use to do all of these examples. So the refactoring book comes with a ton of very detailed examples, all written in Java. And they're quite long examples, which are necessary to really nail down what these refactoring moves look like. But so I wanted to do all of this in R, and I wanted to make, hopefully this code, I hope you don't think it's too simple. I made it quite simple, just so we can talk about the principles. And I'm reminding you of this short link, because now you're about to see all these snippets. Each one fits on a slide, so they're not huge, but if you wanted to find them later. So I'm about to give you another quiz discussion exercise right here. OK. So on the left are some possible inputs, x, to our Bizarro function. On the right are outputs. So I'm going to give you another minute-ish to think quietly with yourself or discuss with your neighbor, like, what do you think Bizarro does? OK, have at it. OK, again, sorry to interrupt your chatting. You can continue it later. Hopefully people came to the conclusion that Bizarro seems to invert things, somehow produce some reasonable definition of the opposite, or whatever you put in. So we're about to build Bizarro in many different ways, using different constructs in R, starting with the simplest and getting up to at least to some object-oriented approach. So I'm starting here, not because I think lots of us write code this way right now, although I certainly have places on my computer where this sort of thing is, but more to start at the beginning. So let's say I'm sort of developing my code, and sometimes I enter a numeric input or sometimes a logical, and I toggle between those two worlds by commenting and uncommenting things. And then I have an early version of what's going to become Bizarro. And again, I comment and uncomment logic, basically, in this cat statement to produce different outputs. So if I send 1, 2, 3, 4, 5 in, -1, -2, et cetera, comes out. And then to try it on a new input, I just change where my comments are, uncomment, decomment things. So you don't survive long writing code like this, but you actually see quite a lot of this early on in scripts, and then also when people are in a big hurry, sometimes it seems easier. But so tip number 1 is you don't want to stick with that kind of mode for long. So do not comment and uncomment sections, especially when you need to do it in concert in multiple places that you will never, ever keep track of. So first thing you might do is get rid of that inner comment, decomment step by properly using an if-else. So if you have a numeric input x, you return -x. Otherwise, we do the logical negation. So we're also clearly only anticipating a pretty narrow set of inputs right now, but that's fine. So tip number 2 is use if-else in moderation, which is the rest of the talk. And if you are going to use if-else, I think you should describe it in really grandiose terms. So this was the best example or definition I've seen lately. It was in a Twitter conversation. The tweet is linked there of people deeply, deeply tired of breathless AI hype. So you can describe it as a one-layer neural network with identity activation and no hidden layers, and it will make you feel better. Next step up, put your if-else inside a function. So now we finally have a Bizarro function that feels so much better. So now we've defined Bizarro. It's still quite simple, and we can call it on different inputs, and we're still getting the same outputs. So this is eyeball-o-metric testing that you would normally make into unit tests that you're constantly running as you refactor something. So tip number 3, use functions. And we're not going to get a chance to really explore this idea because it wouldn't fit well on slides, but a few little functions is usually much better than writing the monster function, which I think many people, I write monster functions and then have to break them up after the fact. And another thing that we won't see a lot but is covered really well in the refactoring book is that sometimes a small, well-named helper function, even a function that you only call once, is a better move than leaving all that logic in the monster function with a lot of comments. And that was like a light bulb for me from that refactoring book. All right, so this is an example of code I don't like so much. And it's producing pretty much the same output as before. Like we've started to actually admit that people might give us other types of input, and we're going to throw a nicer looking error. But what are we doing? So we are artisanally taking the class of X and getting the first element. And so we're asking, is the class numeric? Is it integer? And we dispatch negative X. And if the class of X, at least the first element of that vector, is logical, we're going to use negation. So we're getting the same results as before. And if someone throws unexpected input, we're starting to at least get a nice error message. I'm not showing you what I wrote there, but so there's a lot to like here. We're throwing a nice error, but I'm not a big fan of all this. So I'd rather see using sort of proper built-in functions for dealing with class or type. And we were using them before, but now I want it to be more obvious why. I think it makes things shorter. It also turns out to be safer. So tip number 4, use proper functions for handling class and type. If there is something built into R itself, that is probably a better decision than you rolling something yourself. And you'll notice these conditions, like the logic inside these ifs, is much nicer to read than this. And again, when people come back to this later and they're trying to figure out when do I enter this piece of code, when do I enter that, it's nicer to have a well-named function. In this case, they were pre-written for us. So simple conditions. And sometimes you need to go write that well-named function to eliminate or hide fussy conditional logic. And so I'm now going to start also showing you some examples in the wild from packages of that. So here's an example from Google Drive that will copy a file on Drive, like from name A to name B. But the Google Drive API, for whatever reason, does not allow you to copy a folder. So I need to make sure that file is not a folder. And so it's kind of fussy to figure out whether something is a folder or folder-ish. So I would rather write a function called isParental. I don't know if that's a great name. It's what I chose. And hide, I don't want this sort of in the main body of my function. I don't call this function many times, but it's nice to be able to just sort of say, is this file parental? I can sort of imagine what that means, and if I need the details, I go look it up and move on. Here's another, I think, moving towards even nicer code, which is we've admitted that we're not going to be able to handle input yet that's not numeric or logical. So again, we have a nice function for that, stop if not. So let's hoist that sanity check up to the top. And then it means we don't have to sort of have that nagging worry of bad input as we keep going and eventually sort of fall out through a stop, maybe. So you do give up the really nice custom error message, but so for internal developer-facing functions that shouldn't fail, this can be a really nice way to handle that. So hoist your quick stops and your quick returns to the top. This is actually called using a guard clause. And it enables you to clarify and emphasize what's called the happy path, which is the path that you hope execution follows, as opposed to prioritizing the unhappy path. All right, so here we come to one of the biggest examples, and it's kind of intentional. And again, this is stolen from a blog post, modified, translated from whatever language is into R. And the credit and snippet is in that site. So we have a function called getSomeData, and it takes some configuration information and an out file. And it checks if the config is okay, if so, checks if it can write to the out file, if so, checks if it can open the network connection using that config. All right, so we finally are like have a permission to do things. So we try to get some data from the network. If the data makes sense, we beautify it, write it, return true. Then we return okay, why am I here? So then I have to go back up here and realize, all right, I got data, but it doesn't make sense, so I return false. Now I'm stopping because I can't access the network. Where does that go? And so you end up having these sort of oniony functions where when you read them in a linear fashion, you're falling down and down and down into conditions that were like a long time ago that you saw what you were actually checking. So here's another way to write exactly the same function. If I have a bad config, stop. If I cannot write the out file, stop. If I cannot open the network, stop. Now I'm on the happy path. I get the data. Does it make sense? No, false. Beautify, write it, true. So here they are next to each other, and I've purposely arranged things so they have exactly the same number of lines. But this is what I kind of mean by code smells and feels. Like if I open a file and I know that something's gone wrong in checking all of these things, like I am much happier to be facing this than that. And I think it's because when you're 3 layers in, you're still carrying around the mental burden of all the other branches you could possibly be on, and that wherever you get dumped out, you kind of have to think about other ways people could have gotten here. And so I just tend to find, and it's not just me, but I'm telling you why this type of code is popular with many people, because sort of the mental carrying capacity is less for the thing on the right. So it made me think of Yoda. There is no else, there is only if. So you'll notice, well, on the left, every if has an else. On the right, we have no else. So these are very extreme patterns, and you rarely live in one versus the other. But every if does not need an else if you exit or stop, if you exit or return. I want to coin, only for the span of this hour, an acronym. So TMI, you might think it means too much information. I'm going to quickly compute something called total meat indentation, which I have created out of thin air. I don't even think it's a great term. But I wanted a way to compare these two pieces of code. And so humor me, imagine that we could maybe agree that these are the meat lines. Like these are the lines that actually do things. They're not control flow. They're not error handling. And so here's where they are in the two versions. And I literally computed like how many times I've indented over here versus there. So this is just one way. I'm sure we could all quibble with about it. But if you compare this like highly nested conditional code to the code that takes advantage of early exits, the total indentation on the left is 17 versus 1. Or if you care about the minimum meat indentation, it's 3 versus 0. And I would argue, like if you can keep functionality, keep extensibility, it's more fun to work on code where these numbers are low. But I did just make that up. But anyway, hopefully it's let us get concrete. Another example in the wild, I've only shown you early stops. But another way this works is to turn that on its head. So this is an example, again, from Google Drive, and it's the sort of general purpose function that processes responses from the API. So it checks if the status code is 204. If that's true, there is no payload. You've just succeeded, and good luck. True. If the status code is in the 200s, you've also succeeded, but there is payload, and you need to go get it and return that. So we return, these are early returns, happy returns. And then, if neither of those is true, it means you have a status code that indicates an error, and you're on the unhappy path, which is actually what's prioritized here, and we go on to have 20 or 30 lines of error handling. But so this is another example of hoisting things to the top. If you can get out early, do. So tip 5C is an if block that ends with stop or return does not have to have an else. So you want to recognize early exits. You may still choose to have the else there for reasons of symmetry or like relative importance of the two pieces of code, but you don't have to. And if you don't need it, getting less indentation, I think, is better than lots of indentation in terms of making it easier to reread things. Now I'm going to take a brief interlude. These are not in the online slides. It's only in the live performance. And with all the love in my heart, I was thinking about indentation, and I remembered hearing, I think, on the podcast that Roger has some extreme views on indentation. So I consulted his data science loved ones to confirm this, and they were like, yes, I'll pay you to give this talk. Let me point you to some code. So some people believe that an indentation is 4 spaces. Some people believe it's 2. I think Roger believes it's 8. I was like, are you kidding? And then they showed me. It is in fact true. So every time Roger gets deeper and deeper in conditional logic, he has to go 8 spaces more in. Here, it makes you more prone to break lines and to make things even or short and spaced out. I also found interesting new lines at the end of some files. So this is going to be our follow-up with Roger, what that is about. So this is Roger's view on code, that this is how your code will breathe. And I figure he's spent this year now in Australia. He has lots of friends, and that they would enjoy hearing more about Roger's indentation habits and beliefs. And end of the interruption. You'll never see those slides again, like it was only live. It's special to this location. So the next version of Bizarro, you'll see if you look at the file name, I call it if-else-a-palooza. So now I'm starting to handle more types of input. I'm trying to make this thing more capable. So if x is numeric, I dispatch the usual minus x. If it's logical, I negate. Oh my gosh, we're handling character data now. I apply the stir reverse function, which I've written. I can show it to you if you want it, but it's what did the dessert, stressed, God, dog thing. It just inverts the string. If it's a factor, decided that the way to invert a factor would be to reverse its levels. And then if you've made it this far, we're still going to stop. So again, using my minimum meat indentation or total meat indentation, we don't do so well here. And in particular, there's not a single line of meat code at the top level. Nothing is at the top level of this function. But there's something you may have started to notice here, is that all of our conditions are about the class or the type of X. So when you notice that your conditions deal with class, you may very well want to rewrite your thing using a proper object-oriented system. And so this comes up a lot in the refactoring book, namely because it's a Java-based book. But so the CS jargon for that, should you care to know, is called polymorphism. That's what people are talking about when they use that word. So here's our first crack, and this is super simple, maybe not best practices around writing S3. So I'm going to show you this using S3, which is R's first and simplest system for writing object-oriented code. So here I'm creating Bizarro. This is the function it's going to feel like a user is calling. I'm writing what's called a generic, and it's going to take the input X, and through some magical process, it's going to use method Bizarro, whatever that means. But that's sort of, this is a standard boilerplate way to create a generic. And at the very least, I have to create one method, which is what's down here. And I'm going to first create a default method. So once I have other methods, if X's don't match those methods, they're going to come here. So you often have a default method that says, I do not know how to do what you're asking me to do, and I don't know how great that is, but it's fine. Okay, so this is our default method. This is kind of the bare minimum experiment we need. I'm actually going to call Bizarro on all my standard inputs now, and I get errors across the board, which is what I would expect. I haven't actually written any methods that do anything yet, but I'm happy because it's throwing my error. Right, so that means that I've succeeded in setting up this general structure, which I think is usually a great way to write something that you find a little more complicated, is to try to find very early ways to prove that you've had success and then make things more complicated. So now I'm going to take all this logic that we've been developing in other versions of Bizarro and write my actual methods. So instead of saying is numeric X, I write the name of my generic, and then the numeric goes here. So Bizarro.numeric is going to use our usual logic, return minus X, and so on and so forth. And it allows me to add the fact that we're starting to have less bookkeeping code, all the if else, and we're sort of using higher level abstractions, mean that I can also show you all these methods on one page, and now I get to add one for data frame. So if a data frame gets sent through here, we're going to apply Bizarro to the names, which is actually going to dispatch the character method, and then we're going to recursively apply Bizarro to the columns. Okay, but so having dealt with the most common columns you expect, it becomes fairly easy to write the method for data frame. This is stir reverse if you've been dying to see it. Oops. Okay, so now I can call my eyebolometric tests again and call Bizarro on all the usual inputs. And I love this result in particular. But it kind of we've built up a pretty powerful Bizarro function now, and you have seen the entirety of the code. And there is a lot of conditional logic in some sense in there, and we used this tower of abstraction to create it, but hopefully each individual step was not that difficult. So tip 6, again, you can avoid a lot of explicit conditionals in certain cases if it's time to create classes and methods. And so now I'm going to go through a few kind of miscellaneous ways to deal with conditional logic problems in R. So a really important function to know about is called switch. And it allows you to put, it's usually a string, it could be an integer in, and then whatever that is, it goes and dispatches the usual logic. So this is going to produce the same behavior as all the versions of Bizarro you've seen, but with very different code. I wouldn't actually use switch here. I don't like this sort of manual handling of class, but I wanted to show you switch. And here's an in the wild better example of switch taken out of string R. So the stir pad function will put something, usually white space, on the left, right, or both to pad a string out to a given width. And so this is, I think, a classic use of switch where we actually have a string already, left, right, or both. And then we are using a slightly different stringy function inside the switch to return the padded output. So I think that's a really great example of using switch. So tip 7, switch is ideal if you need to dispatch different logic based on a string as opposed to class or type. And remember, you're allowed to write the helper function that might combine different information to produce that string so that you can call switch. Another case that happens a lot is when you have conditional logic and you're data cleaning. So here's an example. I'm making a little data frame of mythical people, ages 0, 4, 10, 15, 24, 55, and I'm going to categorize them as baby, kid, teen, or adult. And I'm showing you the case when function from dplyr, and it's a little bit like switch, like your data is basically going to sort of filter through here, and the first thing that it fulfills is what it will be recoded as. It's also a little bit like cut. But so it can be a really nice, concise alternative to the big, hairy, nested if-elses that you might write in that same scenario. So again, these two pieces of code will produce the same vector, but I find this a little bit easier to read and a little bit easier to write. So dplyr case when is ideal when you need to dispatch different data based on data, maybe with some logic. And the last miscellany example I'll show you is a little operator that we use a lot inside tidyverse and r-lib packages. It's exported by rlang and purrr at the very least. I tried to get a name for it so that I could talk about it in this talk, and no one could really give me one. So, but I think we've decided we might call it a coalescing or. But what it's an infix operator, so it's going to take two things, sort of one thing on its left, one thing's on its right. And if that first input is null, it returns y. Y is a fallback. If it's not null, if that input is not null, it returns the input. So again, it replaces like inline constructions of that form. And now I'm going to go straight to an in the wild example of how we use this a lot in the tidyverse and r-lib packages. This one's from DevTools. And this is probably not an exported function. But so frequently we use null for an argument that does not have to be set, as opposed to letting it be missing and checking missing. So that means when you come down and you need this username, you can write these sort of chains of these things. So if the user gave me a username, use it. Otherwise, see if there's an option with this name. Otherwise, stop. And this would, if you don't write it with this little infix operator, it's a nested conditional, I think 3 layers, right? So again, and that's still what's happening, is just, this is maybe a nicer way to read it. And certainly once you get used to reading and writing these, they feel a bit more friendly. All right, so to review, this is the end. I think the highest level summary I could come up from this is write simple conditions, use helper functions. Sometimes you write helper functions in order to make your conditions simple. Use everything available to you in base R or an add-on package to handle class and type properly and not yourself necessarily. And feel free to return and exit early. That is a semi-controversial view, I should say, and it's not as advisable in every language, but I sure think it works well a lot in R. And here are the 4 main tricks I would say that I showed for when you detect overly complicated or unreadable conditional logic in your code. Is it time for polymorphism, using switch, using case when, or this coalescing or? These are all remedies for you. And you're still writing the same if-else, but maybe in a way that's easier for someone to redigest. And so I just want to conclude with this. Maybe it's strange to go this deeply into little bitty code snippets, but I picked this topic because I think all of us have a lot of conditional logic in our code, and it's often, I think, what makes code hard to reabsorb. And so I think it's directly relevant. I hope that when you go back to your code on Monday, you look at it just a little bit differently. And I think it's great to have a worked, precise example of what detecting a code smell and having a list of refactoring moves, what that actually looks like. And so if you think of that slide I had of all the official code smells, you could give a talk like this on most of those in R, and it would be a really interesting set of topics to move through to like gradually change the way you write things. And without further ado, thank you very much for your attention. It's been a great conference.
So we've got time for some questions. Yes.
Great talk. Thank you very much. So I have experienced once or twice or more times that some of the code that I write, which I not always, but sometimes I write code that actually looks okay. And what I write, when I show this to people that are not as experienced, they will see it as really kind of difficult to read because I'm using things that they are not used to, like switch or using this infix type operation and so on, because this seems like magic, and writing it the unrefactored way with less if else loops might be strange, but it's understandable because they're using constructs that they know and they haven't tried to written code. It's something that you don't do.
Definitely. I'm going to repeat that a little, just, I don't know, it seems like a good idea for like the live stream or whatever, if that worked. So Thomas was confessing, he never writes smelly code. He uses all of these abstractions all of the time. But if someone else reads it or needs to work on it who hasn't bought in to this set of refactorings, for example, some of it can be harder to read because things look unfamiliar. So yes, because I've also had this feeling myself. I would say I've had to work through some of that even in the past sort of year and a half that I've been at our studio. And then I especially remember this from my life back as a prof when I would work with computer science students, I think, who had absorbed a lot of this more. And in particular, I felt like they would write a function to do anything. And I'm always going elsewhere in the project to figure out what this is, and I'm like, oh my God, that's one line of code. And it would irritate me, although I'm more sympathetic to that now. So of course, all of these things need to be done in moderation. But I started to realize that maybe I didn't really need to see the body of that function, or not right then, and it was nice to have this short version of it. So I think it's the kind of thing that it depends on who your audience is, and if it's future you, or I showed you the people that I'm working most closely with, implicitly and to a certain increasing extent explicitly, like we're doing a lot of code review and articulating design standards, we've all kind of agreed that we believe this. And as I said, this talk caused a lot of discussion even among the tidyverse team. Like not everyone feels the same about all of these practices. So to a certain extent, I think you do have to build consensus on like what your shop does. And your shop might be you. You can do whatever you want. And then especially, I guess, if you're writing code for an expository nature, you might use the most sort of basic constructs possible and just use if else. So it really depends, I guess, on the context. I guess you knew that would be the answer, but the exciting question from our core.
Just one other option you do sometimes have, if it's appropriate, is to work with a GNU-style literate programming setup. That sometimes you can avoid writing functions if avoiding writing functions is perhaps a performance issue, but you could still get the cleanliness of having broken things out that way with code chunks with no web or one of those options.
Oh,
like
yeah. So I think what Luke's discussing is, well, depending on what you're doing, like if this were embedded in a script, a data analysis script or something with Sweave and knitr and literate programming environments, you have even a greater set of options available to you for exposing and hiding different pieces of code along the way. And I think things like chunk externalization are available to you. Like there's other tools that I think are sort of morally on the same wavelength, where you can sort of dial back the level of detail that you're staring at any given time. I don't know, maybe I'm not deciding, they're deciding. The microphone people are deciding.
I tend to get a very high proliferation of functions, helper functions, for like that is supposed to help different classes and things. So do you have any tip on where to put all these functions in a good way?
A talk that I've seriously considered giving is called utils.r. Utils.r is a common place for people to dump helpers, but so like one extreme, that helper you saw me is parental. I think that actually does live in some place like that, but some helpers you only call once. Sometimes you actually define them in the body of the function, and then sometimes there's helpers specific to that file at the bottom of that file, and I think helpers you call from multiple places might go in utils.r. I don't know how common that is in other languages. It does seem like a bit of a just punting on things to dump things there. But I've always thought that doing a global analysis of utils.r would be very interesting. And I've done a little bit of that informally because you tend to see the same things in everyone's utils.r, which of course suggests things that like, maybe we should put all of these in one package, or maybe they should be in base. But then what's also nice about having the helpers in your own utils.r is they don't have to be nearly as robust as a version that was official. But I think that's a common place to put them. It's a fine tradition anyway. I'll put it that way.
Hi, Jimmy. Thanks. I'm in the process of finishing my PhD, and I've just realized that what I'm doing when I clean up my code is called refactoring. So thank you. I knew it spelt, but I didn't know I was doing refactoring. What I wanted to know was the textbook you showed, you said the examples are in JavaScript, is that correct?
Java.
Yeah, if I wanted to start somewhere to understand more about refactoring, is that the place to go, or?
You could, certainly. And the same author, Martin Fowler, has a blog, which is how I found him to begin with. And a lot of the blogs are, I think, short and more accessible versions of pieces of the book. So his blog might be a good place. And then in the README for this talk, I linked to other people. There's a lot of people blogging about the craft of code, especially in other languages. So one of the people I linked to, most of them are about C++. But I don't find their code examples, like I don't personally write Java, I do write C++, they're not that hard to read. So I wouldn't let that be too discouraging. And if anything, the pain you feel reading through those snippets in another language, to the extent that you can still make progress quickly, is probably good pain, because it's good to see these principles played out in a different language and realize you can move them from Java to R, and like it doesn't really matter in many cases. So I think it is pretty readable.
Thanks.
Nick really wants to ask his question.
How do you tell someone when their code smells bad? Like, do you have any tips?
See, how do you tell someone their code smells bad? See, that's part of why I think these names are great. Because if you're reviewing someone's code and you say, there's a little bit of speculative generality here, like it feels friendly, and like having these short names that are a bit whimsical, I think actually help talk about it in a more collegial way. So in fact, I think and it's like so much more concise than saying, have we ever actually seen a such and such? Like, why do we have code to account for that? And so I think that's another reason that the code smells are a good idea. They're concise, and it's easier to tell someone that I think you have a primitive obsession than why don't you start using higher level structures? So I think the names can help.
Okay, so that's all we have time for. You probably won't be able to grab Jenny afterwards and make her answer more questions, but she is around. So let's thank Jenny for her talk.
Thanks.